Writing net ionic equations. Balance the reaction if needed, assign oxidation numbers, write the oxidation or reduction half reactions, and then write the net ionic equation. So the first thing that we're going to do here is see if we need to balance this equation. So when I look at this equation, I see 1 Cu, 1 Cu, 1 Au, and 1 Au. But when I look at this acetate ion right here, I see that there are 3 on the reactant side and 2 acetate ions on the product side. Therefore, I need to make these equal to each other. The only way that I can do that is by putting in coefficients. So the smallest number that both 3 and 2 will divide into is 6. So I'm going to put 6 over the top of those. I know that 2 times 3 will give me 6, and 3 times 2 will give me 6. Once I've established that, I know that I will also need a 2 in front of the Au and a 3 in front of the Cu. And therefore, my equation is balanced. So I'm now going to take a moment and I'm going to get rid of these 6's, because the next thing that I need to do is assign oxidation numbers. I know that any element by itself will have an overall oxidation number of 0. So the Cu here is going to be 0, and the Au right here is going to be 0. If I uncrisscross the 3 right here, I know that the charge on Au will be plus 3, and very similarly, the charge on the Cu will be plus 2, because again, if I uncrisscross this 2, copper will be plus 2. Then I need to identify what is happening here. So what is undergoing oxidation? I can see that Cu is going from 0 to plus 2. My oxidation number is becoming more positive. So when I write this oxidation half reaction, I'm going to write 3 Cu0 arrow 3 Cu plus 2, and then I need to think about the total number of electrons lost. Cu0 to Cu plus 2 is a loss of 2 electrons, but because I have that 3 in front of it, my coefficient, I'm going to multiply that 3 by the 2 electrons that are lost. So the total number of electrons lost here will be 6. At the same time, the Au is going from plus 3 to 0. That is gaining 3 electrons. So I'm going to write 2 Au plus 3 plus some number of electrons gained yields 2 Au 0. For the Au going from plus 3 to 0, that means I need to gain 3 electrons. But again, because I have this coefficient of 2 in front of it, that means I'm going to be gaining a total of 6 electrons. So now the number of electrons lost equals the number of electrons gained, which makes sense when you're dealing with a balanced chemical reaction. The next thing I'm going to do is figure out what is the spectator ion. Well, I can see that this acetate ion right here with an overall charge of -1 has not changed at all as we go from reactants to products. So the spectator ion in this situation is C2H3O2 minus 1. Now what I'm going to do is write my balanced net ionic equation. I'm going to divide these two half reactions into 2 parts, my reactant side and my product side. I'm going to cancel my electrons, and then I'm going to rewrite this net ionic equation combining the 2 half reactions together. So as a result, I'm going to get 3Cu0 plus 2Au plus 3 yields 3Cu plus 2 plus 2Au0. And as a result, I have a balanced net ionic equation.